Okay, chapter 4, number 11. I'm actually going to go through 2 different ways to do this problem. Now, the first way that I would do this would be from noticing that base 4 and 1/2 can be the same base if we change it. So base 4 can be changed to 2 squared. Right, so that 4 to the negative x can be rewritten as 2 squared times negative x. So that was our 4 to the negative x. I don't know if you can read a little right, use that on your own paper. But. So I changed my 4 to 2 squared, and then that squared is going to have to multiply the negative x that's already there. And then likewise, I can change the 1/2 to a 2 to the negative 1, because it's a reciprocal. So if you notice that you can do a same base like that, then I feel like this is probably the easiest way to do the problem. And once you've got the same base, you can just set the exponents equal to each other. So yeah, I just multiply those together. And now just solve. -1 divided by -2 is +1/2, and we're done. Now, if in a test your brain isn't necessarily finding everything that you should maybe be paying attention to because you're stressed and you're trying to get through it in a certain amount of time, maybe you might see, oh, it's an exponential problem, I need to use a log. Okay, take the log of each side. So you can do log or you can do natural log, it doesn't matter. Because either way, either one of them is on the calculator. Oh, but don't switch it, don't do the different thing on each side. Do the same thing on each side. So that's, I like to call that the golden rule, do the same thing to both sides. Treat them the same. Okay? But what's the advantage of this? Well, now we can move this here. So we have negative x times the log of 4 equals the log of 1/2. And now we can do x equals the log of 1/2 divided by the negative log of 4. And then you can just put that in a calculator and get, I mean, you might think, oh, I'm going to get a weird decimal answer, but watch what happens. Try it. Theoretically, we should get 1/2. Sure you put in parentheses. I know the thing about these calculators that worries me, this is why I want you to practice using them if you're doing some of my tests, is you've got to put in your own parentheses. So when I say put in parentheses, that means like right here, here, and sometimes I would even, just to be sure, do something there. Just to make sure everything's doing it in the order it's supposed to be done. Calculators are really picky. I mean, they're really like they're not human. They just do exactly what you tell them to, not necessarily what you're thinking that they should do. Okay, what'd you get? 0.5, 1/2. We got the same answer either way. So, don't you agree that this was probably easier? But don't you also agree that if you're in a certain frame of mind, you might just go exponentially use a logarithm? Just forget to do this. So the good news is, same answer either way. Right. With that in mind, I think that takes us, I think I want to do question 14. I don't know if we can